Welcome everyone, I'm Sadmunjur. I am excited to briefly go over the details of our project on estimating human pose with abstract images. To realize one key motivation, let's take a look at the image on the left. As you can see, it's a front view of a subject represented only with 2D key points. Now, if we ask where are the legs of the subject, we can make two guesses. Either they are in front of the subject or they're tucked behind like in a yoga pose. This drives us to explore an occlusion-preserving representation. We color code such representation and call it an abstract image. We also introduce a novel viewpoint encoding scheme to locate camera position with relative to the subject accurately. Before jumping into the pipeline, let's talk about the abstract image. We use two variants in training. The cube variant is generated from a random 3D pose with ray tracing. The flat variant is generated from the limb occlusion matrix and 2D pose heat maps. While we use both variants for training, only the flat variant is used for inference. Next, let's take a look at how viewpoints are encoded. On the left, we encode the azimuth and elevation of the camera relative to the subject. As can be seen, two different cameras can generate the same image. This will confuse the network during training. To tackle this, we rotate the camera arrays with the subject. As a result, we have the same encoding for the same image. To encode pose, we represent each joint relative to their immediate parent. We perform a local coordinate transformation and encode the elevation and azimuth in heat maps. We also introduce the concept of wrapping. Here we allow Gaussian heat maps for both pose and viewpoints to wrap across the edges. We notice significant improvement in pose estimation with wrapping enabled. Now let's take a short walk through the pipeline. In the image to abstract stage, we extract the image features and train one branch for 2D joint heat maps and the other to generate limb occlusion matrix. We use these two to generate the flat variant. In abstract to pose stage, we take a random 3D pose, a viewpoint to generate viewpoint heatmap, pose heatmap, and abstract images. The abstract images are used to train viewpoint and pose network heads. In the reconstruction stage, we take the predicted pose and viewpoint heat maps to reconstruct the pose. For more details about the reconstruction, please refer to the main paper. As can be noted, we used synthetic viewpoints to train our networks. Here we show the viewpoint distribution from training in purple. As can be seen, ours is more uniform than the other datasets. Since we train on augmented viewpoints, we see better cross-dataset performance. Here, our network is only trained on H36M dataset. While it's not our primary focus, we observe comparable performance with the other methods in same dataset benchmark. Before ending the presentation, here are some qualitative results. On the left, we have some images from H36M dataset. On the top right, we have a real-world image of co-author Dr. Hayes, and on the bottom right, an image from 3DPW. Thank you for listening, and please refer to the main paper for more details and ablation studies.